Okay, guys, so we are going to continue our journey of nomenclature of ionic compounds, but we're going to get into what I'm going to term the complicated um, ionic compounds, okay? So hopefully what you've kind of figured out by now is that ionic compounds are always formed between a metal cation and a non-metal anion. These kind of binary ones. And if you recall me talking about on the periodic table, let me grab my periodic table here. Oh, I have gotten rid of it. That's just lovely, 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 lovely. But I'm so sorry. Let me just find my periodic table here so I can take a look. I don't know how I got rid of it. I'm a chemistry professor without a periodic table. It's very sad. Here we go. So, on your periodic table, you have this staircase. That's really what I just wanted to look up was, exactly where the staircase was. And this staircase denotes that to the right-hand side are the nonmetals, and to the left-hand side are the metals. Again, as before, hydrogen is a pain. Hydrogen is a metal, even though it winds up over there. And we've been talking, for the most part, just with these metals. These metals are the main group metals. So the ones that are in the S block of the periodic table, these are called the main group metals. They behave very, very predictively. Everyone in group 1 forms a +1 cation. Everyone in group 2 forms a +2 cation. So those ones behave very simply, very predictably. But what we haven't talked about is all of the rest of these metals. These metals, all the way from the start of the D block to the staircase, except for aluminum. Aluminum will always be +3, are called the transition metals. And the thing about the transition metals is that they have variable charges. They are not predicted. They can form more than one. Cation. It's still cation because all metals make cations. That's one that's not going to go away. All metals make cations, but they form, some of them form some more than one. And so they are not as predictable as the main group metals, the group 1, group 2. The transitions can form more than one. All right, so I'm sorry, I'm trying to find another periodic table here for me to look at so that I'm not lying to you about anything. Here we go. This is what I wanted to see. Okay, so I don't know why this doesn't have this all on there. It's all good. All right, I'm just going to keep going, and we're gonna deal with it. So the question is, do these form ionic compounds? And the answer is absolutely. Absolutely, these guys form ionic compounds, and we need to be able to tell what the name and the formula to name is for these transition metals. So we're going to start easy. Name to formula for the transition metals themselves. So I'm going to try to grab this picture again. So I have my periodic table here that I can use. Kind of went out of view there. That's all right. There we go. So here's my periodic table. I'm going to use it, and we're going to go from the name of the compound to the formula of the compound. So I'm going to start off real easy. We're going to go name to formula. So I want to know what is the chemical formula for iron 2 chloride. Okay, so there's some things about this name that I want us to recognize right away. First of all, it's talking about iron. Iron is here. It is not a main group. It is one of the transitions. The transitions go from the start of the D block all the way over to the staircase. Iron is a transition. That means it's a complicated ionic compound because it has a transition metal cation. Chloride is normal. So we're going to go back to the ions to figure out the chemical formula for this. So we have iron. Iron is Fe. This 2, this is a Roman numeral 2 in parentheses next to it, is the charge on the iron ion. So iron 2 chloride means that you have iron that has a +2 charge. Chloride is in group 7. It's a halogen. Chloride will always have a -1 charge. And now we bring it together in the correct ratios to make it so that overall the ionic compound is neutral. So the chemical formula for this guy is FeCl2. Iron 2 chloride, FeCl2. Let's look at another example. What's the chemical formula for iron 3 chloride? So take a second and think about what's talking there, right? So we have iron. Iron's a transition. It's one of the complicated ones. It has to have its charge and Roman numerals after it. So that Roman numeral 3 means that we have iron that has a +3 charge. Chloride stays the same. Chloride has Cl, it's a halogen, -1. We're going to bring those together in the correct proportions in order to balance out those charges, make it 0. So this is FeCl3. Iron 3 chloride is FeCl3. Let's do another one. Cobalt is another good one that is complicated. It's the transition. So cobalt is right there next door. So cobalt is a transition metal. That's not a main group. So you got to give me its charge in Roman numerals. So I'm going to do cobalt 2 oxide. Okay, so take a second. Think about it. I'm going to drink some water. Just like every other ionic compound, when you're going from the name to the formula, go back to the ions and then balance it out so that the overall charge is 0. So cobalt 2 means that we have cobalt that has a 2+ charge. Oxide is from oxygen, group 6, gains 2 electrons, has a 2- charge. This is a match made in heaven. So cobalt 2 and oxygen 2- means that this chemical compound is COO. Cobalt 2 oxide is the name for that compound. So what I'm trying to really hammer home about this is that the Roman numeral has nothing to do with the subscripts. So a lot of times some students might get confused and think that Roman numeral has something to do with the subscripts. It does not. That Roman numeral is all about what the charge on that particular ion is. Let's do another example so I can really, nail it home. Oh, this is one of my favorites. And students get it wrong a lot. Manganese 4 sulfide. So, again, take a second. Manganese is another one of our transition metals. Manganese is right here. It's one of the transitions, so its charge is in Roman numerals that come next to it. That IV is Roman numeral 4. So that manganese 4 means that we have manganese with a 4+ charge. Sulfide comes from sulfur. Sulfur is in group 6. Gains 2 electrons to look like a noble gas. So it has a 2- charge. Just like everything else that we do, we just need to bring these together in a proportion or in a ratio that overall it has a charge of 0. So manganese has a +4. Sulfide has a -2. That means we need 1 manganese and 2 sulfides. MnS2 is the chemical formula for manganese 4 sulfide. Again, the Roman numerals in parentheses have nothing to do with the subscript. That Roman numeral has everything to do with what the charge is on the ion. Okay, so that's name to formula. Even harder, though, formula to name. Okay, so formula to name for transition metals is absolutely the hardest. I can't get any harder than this. I wouldn't lie to you guys about that. I can't get any harder than transition metal formula to name. I mean, I guess I could throw the polyatomic ions in there, and we'll get to the polyatomic ions in the next video. But for the most part, this is as hard as I can make it. So let me think. Here we go. Let's do, formula to name. I'm already writing out the name. Formula to name. We're going to do Cr. I'm going to make it hard. S3. Yep. CrS3. I want to know what is the name of this compound. So give it a second. I want you guys to think about it. This is tricky. I'm just going to grab my periodic here so I have it in front of me so I can use it. CrS3. What is the name for that compound? So if you're just, sitting there and you want to shout out, chromium sulfide, you're wrong. I wouldn't lie to you. It's trickier than that. So let's analyze this. Let's really get into it. Chromium is here in the periodic table. It is a transition. That means you have to give me the charge on the ion. You know it's going to be chromium something sulfide. But you have to tell me what its charge is. So we have to undo that chemical formula in order to figure out what is the charge on that chromium ion. So this is what I do. We're going to break it down into its pieces. We have a chromium ion. We know it's going to be a positive charge because chromium is a metal. Metals make cations. We have 3 sulfide ions. Sulfide ion comes from sulfur. Sulfur gains 2 electrons to look like a noble gas. So each one of them has a 2-. So we have 3 2 minuses. That means that overall we have -6 for this ionic compound. Overall, this has a 0 charge, right? CrS3 has a charge of 0. So we have a -6 portion coming from the 3 sulfides. That means that this side has to be +6. So this is chromium 6 sulfide. You have to undo the ionic compound in order to figure out what the charge on it is so that you can put it in its name. Let's do another one. I'm going to just give myself some room here. Okay, formula to name. Let's do something interesting. Let's do IR. That might not be one that you had to memorize. That's iridium. Let's do iridium. I had a professor in grad school who did a lot of stuff with iridium. Let's do IRP. Is that one that exists? Yes. IRP. What is the name for IRP? So again, IR is iridium. Iridium is here on the periodic table. That means it's one of the complicated ones. It's a transition metal. So you have to give me the charge on the transition metal. You know it's going to be iridium something phosphide. But you have to tell me the charge as a Roman numeral for the transition metals. So again, we're going to break it into its pieces. We have iridium. We know it's going to have a positive charge. It's a metal. Metals make cations. We have phosphide. Phosphide comes from phosphorus. It's in group 5. Gains 3 electrons to look like a noble gas. So that means it has a 3- charge. Overall, we have a -3 portion. That means this has to have a +3 portion. So this is iridium 3 phosphide. Oh, I'm sorry. I bumped my computer. Okay, let's do another one. Let's go with something easy, and then I'll do another one that's hard. So something a little bit more straightforward. Let's do NiCl2. So again, I'm going to pause for a second while you think about it. Ni is nickel. Nickel is right there. It has, it's one of the transition metals. So you have to give me its charge in Roman numerals. So take it apart into its ions. You have 1 nickel. You know it's going to be positively charged because metals make cations. You have 2 chlorides. Think about what the charge is on a chloride ion, and you have 2 of them. So what must the charge be on the nickel? This guy is nickel 2 chloride. Break it into its pieces. Nickel is going to have a positive charge. We don't know what its positive charge is. That's what we're trying to figure out. 2 chlorides. Chlorine is a halogen. It's in group 7. So it gains 1 electron. So overall, this has a -2. So the nickel must be +2. So that's nickel 2 chloride. Let me do another one that is hard. I'm trying to think. Nickel. Let's do. No, I don't want to do that. Oh, yeah. We can do it this way. Let's do Cu2. Oh, this one's super bizarro land. Cu is copper. One of the transition metals. But there's 2 of them. Be careful. There's 2 of them. Think about oxide. You know that this is going to be copper something oxide. Got to figure out the charge on the copper. We have 2 coppers. We know that they're going to have a positive charge because metals make cations. Oxide is in, oxygen is in group 6. It gains 2 electrons to look like a noble gas. So overall, we have a -2 portion. That means that we have to have a +2 portion. But there's 2 of them. That means each one of our coppers has to be +1. That guy is copper 1 oxide. Copper 1 oxide. Okay. Now I'm going to do just a little tiny bit of practice here because my video is already almost 20 minutes long. This gets really hard when you start to put them all together in one big old chart. Let me actually get a new blank slide. So what I mean by that is if you have name on one side, and this is what your exam questions will look like. You'll have a chart like this. There'll be 10 of them at least, named a formula. And then you'll have a bunch of them, right? So I might give you something like this, and this, and I don't know. And then we might do some like the chart's going to start to get complicated, right? Like we now know simple ionic compounds and we know transition metal compounds. Next slide, you're going to learn polyatomic ionic compounds. And so like all of this starts to build and build and build and build. And this actually gets relatively tricky for students. So I'm going to tell you the best way to approach this is to take your time. Okay, so the way I'm going to think through this, so we're going to go formula to name to formula for some ionic compounds. And these are simple ones yet, or these don't have the polyatomics yet. We'll get there eventually. But we're going to go formula to name. So this is kind of the thought process that I take, kind of your decision tree. We have NaCl. It's ionic because sodium is a metal. Ionic compounds form between metals and nonmetals. Sodium is in group 1 of the periodic table. That means it is not a transition. Since it is not a transition metal, you name it very simply. Sodium is the cation, it comes first. Chloride is the anion, it comes second, it changes its ending to IDE. So when it's not transition, that is straightforward. Sodium chloride, formula to name. Fe2O3. Okay, the decision tree is it ionic? Yes. Iron is a metal. Now, is iron a transition or not a transition? Iron is absolutely a transition metal. It's there in the D block of the periodic table. It ends with 1, 2, 3, 4, 5, 6. 3d6 is the end of its its electronic configuration. Since it's a transition, you know that you need those Roman numerals. Okay, so like danger, 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 transition, you need Roman numerals. You know that it's going to be iron something oxide. You got to figure out its charge. So we're going to break it down into its ions. We have 2 iron ions. We know that's going to be a positive charge because metals make cations. And we have 3 oxide ions. Oxygen is in group 6, gains 2 electrons, has a 2- charge. Overall, this has a -6. That means that this side has to come up to a +6, because 6 minus 6 is 0. Overall, it has a 0 charge. So the negative portion is -6. The positive portion has to be +6, but there's 2 of them. So each iron has to have a +3 charge. So this is iron 3 oxide. Nis, it is ionic because nickel is a metal. Nickel is absolutely one of the transitions, so danger, danger, danger. We need Roman numerals. So this is going to be nickel something sulfide. Break it into its pieces. I'm going to do that up here. We have nickel. It's going to have a positive charge because metals make cations. Sulfur is in group 6, gains 2 electrons to look like a noble gas. That means that this has to be nickel 2 sulfide. All right, so you can see it's a little bit trickier when you start to have many things together in the same chart. So now we have strontium bromide, named a formula. Strontium is a main group metal. It's an alkaline earth metal. That means it will have a 2+ charge always. That's why there are no Roman numerals. It's not a transition. It's a main group. Bromide is a halogen in group 7. Gains 1 electron, has a -1 charge. We're going to bring those together in a ratio that overall it has a charge of 0. So that's 1 strontium to 2 bromides. SrBr2 is the chemical formula. Iron 3 chloride. Iron has a 3+ charge because the Roman numeral tells us iron is a transition, tells us that it has a +3 charge. Chloride is a halogen, has a -1 charge. We're going to bring them together in a ratio such that overall it comes out to be 0. So we're going to have 1 iron to 3 chlorides. FeCl3 is iron 3 chloride. And last but certainly not least, we have chromium 2 phosphide. Chromium 2 means we have chromium with a 2+ charge. It's a transition. That's what the Roman numerals are telling us. Phosphide comes from phosphorus. That means it has a -3 charge. We have to bring these together in a ratio that overall is 0. This is the hardest. 2s and 3s. We talked about this a little bit when we talked about balancing chemical equations. 2s and 3s are the hardest. We have to find the least common multiple. Least common multiple is 6, so we're going to need 2 phosphides and 3 chromiums. That gets us up to a +6 and a -6. So the chemical formula is Cr3P2. That's the chemical formula for chromium 2 phosphide.